So in the previous lecture, we have seen the equation for finding out the viscosity of gas at low density. We had two models, that is, one was the rigid sphere model and other the rigorous model and or the Chapman-Enskog theory. And we have seen the equation for this viscosity of the gas using these theories or models. So next we are going to find out the equation for finding out the viscosity of gas mixtures. So this Chapman-Enskog theory has been extended to include multi-component gas mixtures at low density. So for this we can use the semi-empirical formula proposed by Wilk for getting the viscosity of this gas mixtures. The equation is viscosity of mixture is equal to sigma I equal to 1 to n xi mu I by sigma j equal to 1 to n xj phi ij. Here it is a mistake, it is actually xj not xi. So, and the equation for this phi ij is 1 by root 8 into 1 plus mi by mj the whole raised to minus 1 by 2 into 1 plus mu I by mu j the whole raised to 1 by 2 into mj by mi the whole raised to 1 by 4 the whole square. So this is the equation for getting the value of phi ij, and after getting this value you have to substitute in this equation for getting a viscosity of gas mixtures. Now we can see each term, what is meant by each term in this equation. So here n, the small letter n means it is the number of chemical species in the mixture, and this ij, they denote each chemical species. So we have totally n species. This xi, xj, it means it is a mole fraction of species I and j. Then mu I, mu j, that means they are the viscosities of species I and j at the system temperature and pressure. Then capital letter mi and mj, they are the corresponding molecular weights of these species I and j. And we have phi ij. This phi ij is actually a dimensionless parameter. And when I is equal to j, we have the value of phi ij as 1. So, when you are asked to find out the viscosity of gas mixtures, you have to use this equation. So, now we can do a problem based on this. So this is the question. Predict the viscosity of the following gas mixture at 1 atmosphere and 293 Kelvin from the given data on the pure components at 1 atmosphere and 293 Kelvin. So the components or the species present in the gas mixture are carbon dioxide, oxygen and nitrogen. The mole fraction of each of these species is given. Also, the corresponding molecular weights of the species are given and its viscosity is also given. So, you have to find out the viscosity of this gas mixture. So, here we are denoting the species carbon dioxide as 1, oxygen as 2 and nitrogen as 3. So, this is a question given. So, the solution to this question is so when a problem is given like this, you have to form a table. That is the first step. So the table should contain these headings, that is I, j, mi by mj, mu I by mu j, phi ij and sigma xj phi ij. So these are the terms given in that equation. That equation means equation for finding out the viscosity of the gas mixture, that is mu mix. So these are the terms available. So you make it in a table form. And after that, in that question we have actually 3 species are given. So you write I as 1, 2 and 3. I as 1, 2 and 3. Then let us take the first species I. That is, species I is 1. 1 corresponds to carbon dioxide in the question. So, for each of this I, we have a J term. So, this J term will also be 1, 2 and 3. So, this I, that is this 1 will be having a relation with each of these 3 species J. So, you have to find out the corresponding ratios of molecular weights and viscosity for this. So, let us find out Mi by Mj value for this. So, here Mi by Mj means this is species 1. This here also J is 1. So, each of these 1 corresponds to carbon dioxide. So, the ratio of molecular weight of carbon dioxide divided by molecular weight of carbon dioxide. So, that will be equal to 1. So, let us take the second portion. Here, Mi by Mg means molecular weight of carbon dioxide divided by molecular weight of oxygen. The species 2 in the question corresponds to oxygen. So, you find out this value 44.010 divided by 32. The next term is molecular weight of carbon dioxide divided by molecular weight of nitrogen. That is Mi by Mg. So, 44.010 divided by 28.016. So, find out this value also. So, in a similar way, we can find out the mu I by mu j ratio. So, here mu I by mu j will be equal to mu of carbon dioxide divided by mu of carbon dioxide. It will be equal to 1. Here it is mu of carbon dioxide divided by mu of oxygen. So, find out this value. Next is mu of carbon dioxide divided by mu of nitrogen. So, find out this value also. Next, we have to find phi ij for each of these terms. So, the equation for finding out the phi ij is given. It is 1 by root h into that equation you have to use. So, this is the equation 1 by root 8 into 1 plus mi by mj the whole raised to minus 1 by 2 into 1 plus mu I by mu j the whole raised to 1 by 2 into mj by mi the whole raised to 1 by 4 the whole square. So, you know each of these terms. So, substitute in this equation and get the values of phi ij. So, phi ij. So, you will get the values of phi ij as 1.730 and 0.727. Next is you have to determine the value sigma xj phi ij. So, xj here means, so this phi ij here the value is 1 and here the j is for 1, that is carbon dioxide. So, the mole fraction of carbon dioxide multiplied by this phi ij plus mole fraction of oxygen multiplied by this 0.730 plus mole fraction of nitrogen multiplied by this 0.727. So, you will get the value as 0.763 for this component I. For this species I, the value of sigma xj phi ij is equal to 0.763. So, in the similar way, you find out the values for species 2. This species 2 will be having a relation with each of the 3 species, that is with species 1, 2 and 3. So, you find out the ratio Mi by Mj. Here Mi, I corresponds to oxygen and here J corresponds to carbon dioxide. Similar is the case with viscosity. So, for the second term, you can write Mi by Mj means molecular weight of oxygen divided by molecular weight of oxygen. And for the third term, here it will be molecular weight of oxygen divided by molecular weight of nitrogen. So similar is the case with this viscosity. Then as before, find out the values of phi ij for each of these three terms and get the value of sigma xj phi ij. You will get it as 1.057. And for the third species I, J components are 1, 2 and 3. So you complete this table, find out the ratios of Mi by Mj, Mu by Mu j, find out phi ij. And here for the third species, you will get the value sigma xj phi ij as 1.049. So after completing this table, you have to use the equation mu mix is equal to sigma I is equal to 1 to n xi mu I by sigma j equal to 1 to n xj phi ij. Here we have totally 3 species, so our n value is equal to 3. So we know this term. This term is already, we have found out it. So xi mu I, you have to sum this term. Summation of xi mu I by sigma j equal to 1 to 3 xj phi ij. So xi, in the first case, it is the mole fraction of carbon dioxide multiplied by viscosity of carbon dioxide, the whole divided by 0.763 plus. Next is the oxygen term, mole fraction of oxygen multiplied by viscosity of oxygen whole divided by 1.057 plus mole fraction of nitrogen multiplied by viscosity of nitrogen divided by 1.049. You will get it as 1714 into 10 raised to minus 7 gram per centimeter second. So this is the viscosity of this mixture, gas mixture. So do one thing, you complete this table and submit in ET lab as today's classwork.